Okay, 7.4, trigonometry. Objective. Students will be able to find trigonomic ratios using right triangles and solve problems using trigonomic ratios. Okay. Trigonometry, it's actually, there's a whole class that you could take on this later on, but we're just doing some real basic stuff with trigonometry here in geometry. And it literally just means triangle, so trig is, and then onometry means measure, so triangle measure. So the measure of triangles, really. And we have this kind of this like word that we use. If we can just remember this one word, we can pretty much set up any trig problem because they all set up in the same pattern. And this is the word. And I did a little funny story about this guy that I met named Chief SOHCAHTOA. SOHCAHTOA. Okay, if you can remember that, SOHCAHTOA, which you will use for the rest of your math career, whether this is the last class you take in math, or if you keep going on and on in math, you're going to use that saying all the time. Obviously I'm a math teacher, so I use it all the time, but I remember using this all through high school and in college and stuff. So SOHCAHTOA. What that means is we have three trig ratios that we're going to learn, and the first one is sine, cosine, and tangent. And if you have some triangle, a right triangle specifically, like this, the sine of an angle, so if you were to take, you have your calculator and there's that little SIN button, so sine, cosine, tangent. The sine of an angle, sine, is equal to the ratio of the opposite side of that angle and its hypotenuse. So look, here's A, right? Here's angle A. The side opposite of it is over here, and the hypotenuse right there. So we could actually take the measure of the opposite side, which is why I would just put a little O, or OPP for opposite, on the top, and the hypotenuse, whatever the hypotenuse is, on the bottom. So the sine of an angle will always be equal to the ratio of the opposite side over the hypotenuse. And the cosine of the angle, you kind of guess it. If it's ca, what is it going to be equal to? Well, it's going to be equal to the adjacent side over the hypotenuse. So cosine, we have ca. Cosine equals the adjacent over the hypotenuse. Adjacent goes on top, hypotenuse goes on bottom. So you should be able to kind of guess what the tangent of an angle is equal to. So here's the angle again, and we're going to do the tangent, and this time it's O and A, right? So SOHCAHTOA. So that's going to be the opposite over the adjacent. So, like I said, you're going to want to just say this over and over and over again. Say it so many times that you cannot forget it. SOHCAHTOA, SOHCAHTOA. It'll make your life so much easier. All right, let's go on to the next page. So, let's see how this works. They give us this triangle, right? And now we have sides of the triangle, but we don't know what any of these angle measures are. But see, we could actually figure it out. So we're gonna first start off practicing by just figuring out how we will write the ratios for these. So let's first do the sine of R. Well, here's angle R, and I'm gonna mark it. So we have R, just so we can kind of see it a little bit. Well, the sine of angle R, remember, sine is so opposite over hypotenuse. Well, the opposite would be 4, and the hypotenuse would be 5. So we could just say sine of R equals 4/5. And the cosine of R, well, remember, ca for cosine is the adjacent side, so 3 means that it's right next to it, and the hypotenuse, which is 5. So that's going to be 3/5. And the tangent of R is going to be the opposite over the adjacent. So the opposite is 4, the adjacent is 3, so it's going to be 4/3. Okay, so you just come up with the trig ratios. I'm going to take this opportunity to show you how you would do this in your calculator. I don't have the benefit of throwing a calculator up on the screen here, but I'm going to show you what this looks like. So let's just do sine R equals 4/5 here. Do it up here. So I have sine R equals 4/5. fifths. Let's say I wanted to figure out what r was. I wanted to solve for r. I would have to get rid of this sine thing next to it, because this is really the sine of r. So a better way of thinking is like this is a function that goes to r. So we're going to do something to this angle measure of r. An angle measure, if it's a right triangle, right, it's somewhere between like 0 and 90. So we're going to plug that in there, and then when we put that into the calculator and do the sine thing, it's going to convert it to the ratio of opposite or hypotenuse. That's what these trig functions do. They convert angle measures to ratios of sides. And that's really handy when we're solving parts of right triangles. So anyway, like I was saying, in order to get that r all by itself, what we're going to have to do is we're going to have to take the inverse sine of both sides. So let me show you what that looks like. We would just take the inverse function of sine, which on your calculator looks like that, and we're going to do that to both sides. And so what happens is these two operations cancel each other out, kind of like, right? Kind of like if I was to have r and I had a square root of it, and I take the square of it, right? That would just equal r. That's kind of the same idea here. I mean, it's not being squared; it's a whole different function entirely, but it's the opposite. So we would be left with an r on this side and a sine -1 4/5 on this side. And so what I want you to do is just find that function on your calculator and see if you can plug it in. I'm going to do that right now. Let's see. So sometimes it takes, you got to use a shift key to get to that, because it's not when it's right there. And it may say arc sine, or it may say sine -1, like I have up there. There's a few different things that it might say. And so usually you'll press that button first, and then you'll put in that ratio that we have, which is 4/5. And just hit equals. And I got back that r is 53.13 degrees. Okay. That's handy because we're going to have problems like that, especially in your homework. But what's really important right now, for what I want you guys to be able to see, is how we set up these ratios. Because once we set them up, the calculator can do most of the work for us from there on. So I'm going to just kind of throw this out here and zoom up on this. Get rid of this stuff. Okay. So what I want you guys to do is see if you can figure out how you're going to set up these ratios for sine s, cosine s, and tangent s using the same triangle. What I'll do here is I'll mark it with blue just to kind of give you a visual. And so just to also help you, again, this is still the hypotenuse, but now 3 is the opposite of s and 4 is the adjacent. So I would hit pause now, see if you could try it on your own, and then I'll put the answers up. Okay, so here's what I got. I got the sine s equals 3/5, cosine s is 4/5, and tangent s is 3/4. Something kind of interesting to point out, since these are two angles of the same right triangle, there's two like other angles of the right triangle, something kind of interesting happens. Look, the sine of s is the same thing as the cosine of r, and the cosine of s is the same thing as the sine of r, and the tangent of r is the reciprocal to the tangent of s. So just kind of some neat patterns to think about. You don't have to really know too much about that, but later on in trig and in calculus, those patterns are going to come in real handy. So just kind of neat thing that happens there with trig ratios. All right. Next up, this is what I mean by the calculator can do most of the work. There's going to be problems where you need to just figure out what the cosine of 39 degrees is. And all you have to do is take your calculator out, find that button that says cosine, and this one is probably not, it could still be a shift function where you have to hit shift or second, but this one should be one that you just are able to just press. So cosine of 39 degrees and hit equal. All right, and this will give you a ratio, but it's going to give you a ratio written as a decimal. So for me, I got 0.7, actually just 0.777. Now, a couple of things are really important. Your calculator needs to be in what's called degree mode, and usually it'll just say DEG, but that's degree mode. There's another mode called radian mode that you don't need to know about or use yet, so don't worry about it. But your calculator, you always want it in degree mode. If it's not in degree mode, it's going to kick back something different. In fact, let me see if I can just tell you what it would kick back. If it was not in degree mode, you might get something like, yeah, you would get 0.266. So make sure it's in degree mode, otherwise you're not going to be able to do that. So why don't you go ahead and see if you can get the other trig functions here. So sine of 67, tangent 48, and sine 89. Try it on your own. And you might want to pause the video because I'm going to throw the answers up. Okay, here's what I got. For sine 67, I got 0.921. For tangent 48, I got 0.11, and then I rounded the third one. And for sine 89, I actually got 0.9998. So really, that's rounded to 1. But it's kind of important that you know that it is actually less than 1. Because sine of 90, if you put that in your calculator, sine of 90 is actually equal to 1. So it's kind of important that this is actually a little bit less than 1. But and something kind of neat is the sines and the cosines. They should always stay between, yeah, they actually, for you guys in geometry, they'll probably always stay between 0 and 90, or 0 and 1. So there's be some ratio, right, for 0 to 1. But the tangent can be a lot of different things. So, but just, that's kind of something to know, that it should always get some fraction between 0 and 1 back. And that makes sense if you think about it, because really these are a ratio that represent a side over a hypotenuse, and the side, whatever side it is, should always be shorter than the hypotenuse. So you should always get some fraction where the number on top is smaller than the number on bottom. And that's what all these really are. So, yeah, that's why you would get a number less than 1. Okay, it was at this point, I think, in class that we took a break and did some practice with the worksheet, but I'm going to press forward just because it's just a video. Okay. It says Dakota is standing on the ground 97 yards from the base of a cliff. Okay, remember, guys, when in doubt, draw it out. So let's draw it. Here we go, 97 yards. And here's my cliff. I'm going to make my cliff just like that. Maybe we can call it cliff. Okay. Using a theodolite. Now, I think I showed a picture of this in class, but a theodolite is this it's this tool that you can use to measure angles, basically. And so he used this tool to note that the angle formed by the ground and the line of the site to the top of the cliff. So, you know, if he's standing right here, the angle to the top of that cliff, let's say I drew it right, was 56 degrees. Find the height of the cliff to the nearest yard. So we're assuming that this is a right angle here. Well, we got to figure out what trig ratio we're going to use. So, do I have a hypotenuse? No. Well, let's go back up and look real quick. Actually, we didn't write it here, but if you were to think about it, so, ka, toa, so uses a hypotenuse, or sine uses a hypotenuse because it's SOH, and cosine uses a hypotenuse because it's CAH. So the only real one that's left is probably tangent. So we're going to use tangent, and we're going to use the angle 56 that we have. And now let's think about what we need to know. Well, we know this side, which is the adjacent, but we don't know this side, which is the opposite of 56, right? So let's just call that we'll call that y. So we could say tangent 56 equals toa is opposite y over adjacent 97. And so if I wanted to solve for y, right, I could just multiply both sides by 97. These guys would cancel. And so I have y equals 97 tangent 56. Okay, this you just plug into your calculator. So you take 97 times trig function, you're looking for tangent, and 56 degrees. And I got that y has to be equal to 143.8 yards. Okay, that's all it takes. But I want you guys to try and do it with a different number. Let's say the angle that he found was actually 34 degrees. So that means that you would cross this off, you put a 34 degrees there, and see if you can set it all up again. I'll give you a hint. You're still going to use tangent because your side is going to change. So you're still going to use tangent, but give it a try. give it a try. I'll put the answer up in just a second, so you may want to pause it and try and find it on your own. Okay, you should have gotten 65.43 yards. Yeah, so you should have found. Okay, let's move on to the next page.